this is the video for 4.1b, and we're just going to get a little deeper into that probability density function and just kind of do some new stuff with it. So let me share my screen. And we have here, again, we're talking about the discrete probability function. We know the two main rules. For me, I'm like recording this video like 10 seconds after the last video, so I feel like I've already said this 100 times, but you haven't seen it, maybe for a day or two. So let's talk about our two favorite rules, shall we? We have the sum of the probabilities is equal to 1, and each individual probability is between 0 and 1. Those are the two rules that rule over this chapter. Okay, so we have those two rules. Now we're going to add to it. We're going to calculate the expected value or mean of a I don't know why I made that box so big, of a probability density function. So this is like literally putting everything together. We talked about expected value in chapter 3. We talked about mean in chapter 2. We talked about discrete random variables in the last video, chapter 4. We're putting all of those concepts together. So the way we find the expected value or mean, so we use those words interchangeably, is to multiply each value of x by its probability and then add all of the products. That sum is the mean, which is mu. Okay, let's talk about what that means. First of all, going back to what we know about probability, if the sum of all the probabilities is equal to 1, 100%, this is everything. This is all, everything, which means population. Population mean is mu. Population mean, so that's what we're looking for. We are going to calculate this, and we want to make sure we're using mu for mean. Okay, so here is a pair of fair dice rolled. Remember, we talked about this in the last video. So there's one way to make a 2, a 1 and a 1. There's 2 ways to make a 3, a 1 and a 2, or a 2 and a 1, and so forth. And here's all the probabilities: 1 out of 36, 2 out of 36, 3 out of, they're just reduced, 4 out of 36, 5 out of 36, 6 out of 36, and it goes up, 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 and then it goes back down, 5, 4, 3, 2, 1 out of 36. So the reason it's important to know that we are talking about the whole probability is that we're talking about all 36 in this example, and each fraction is over 36. It's reduced, but you know what I'm saying, like 1 out of 36, 2 out of 36. That's what we would do for the mean, is we would divide by 36. So we don't have to do that step here. We're just going to multiply and then add everything together, and we're going to get our mean. Now, reduced fractions only count for the final answer. So we can do this kind of a little quicker, because multiplying fractions is just multiplying the whole number times the numerator. So 2 times 1 out of 36 is 2 out of 36. And for any of these, if I go too fast, use your calculator, because if you don't know how to multiply fractions by now, it is what it is. Okay, 3 times 1 over 18 is 3 over 18. Again, I'm not going to worry about reducing, because that's a job for the final answer. 4 over 12, 5 over 9. This one's a little trickier because there's no 1 in the numerator, but 6 times 5 is 30, so this is 30 over 36. 7 over 6, again with the 5, so 8 times 5 is 40, 40 over 36. 9 over 9, 10 over 12, 11 over 18, and 12 over 36. All right, step 1, multiply each value of x by its probability. Check. Step 2, add all of the products. Plus, 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 equals. All right, I'm moving my keyboard for this one because this one is a lot of typing. Okay, here we go. So we have 2 out of 36 plus 3 out of 13. No, 3 out of 18. Oh my goodness, I already messed up my 3 out of 18 plus 4 over 12. 5 over 9. You're typing this, right? You're doing this too? Make sure you're doing all this in your calculator so you know how to do it for the test and the project. Or just go faster, then you get the answer and fast forward. 7 over 6. 40 over 36. Now, I told you earlier that they go up and they go down for the probabilities. That's not true for the products because we multiplied each probability by a different number. So that pattern won't stick around. It's just the probabilities. All right, 9 over 9, 10 over 12. It's getting really big. 11 over 18 and 12 over 36. And enter. It's a very pretty number. So this equals 7. So the answer is mu equals 7. And that mean, mu is still mean, actually specifically mu is still population mean, but remember with regards to probability density functions, this is also the expected value. So if the question says find the expected value, that means find the mean. If the question says find the mean, that means find the expected value. So this is very similar to what stuff we did in chapter 3. We just are going back and forth between the vocabulary. Okay, here's a game. Can I see it? All right, I will just try to read because I can't move this thing out of my way. You know what, I'll just make it big. Okay, in a game, participants spin a wheel to win a prize. Okay, the wheel is split into 10 sections, showing how much money, okay, I like this already, each participant can win. 6 wedges show 0, 2 wedges show 100, 1 wedge shows 300, and 1 wedge shows 800. The table below, we don't have a table below, represents the probability density. Okay, well, we got to make the table because I forgot to put it in. So here's what we have. There's split into 10 sections. Okay, so let's draw 10 sections. Cut it in half. Just make your pizza. Is that good? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that works. And it says, so you can put your wedges wherever you want. We're not actually making a game. So if you want to put all your zeros together, that's fine. We can mix it up though. Like I have 800. We got to put a 0 on each side of 800. And then I have 2 100s. Let's see, I'll put the 100 here. 2 100s. I'll make that a 0. Yours doesn't have to look exactly like this. It could be however you want. And then we have a 300. Okay, just give me my blue pen. I don't know why you're being all weird. Okay, anyways, hopefully this works. 300. Oh, I guess I wanted a red pen. Okay, whatever. 1, 2, 3, 4, 5, 6 zeros, a 300, a 100, 2 100s, and an 800. Okay, so we have I already said it. I said 0, 100, 300, and 800. All right, so there's 10 sides. 6 out of 10 sides show a 0. 2 out of 10 sides show 100. 1 out of 10 sides shows 300, and 1 out of 10 sides shows 800. All right, so now I'm going to do this like we did in chapter 3. So maybe the mean equaling the expected value, maybe it'll click a little better. All right, multiply, get 0. Multiply, get, I feel like I could simplify this. So I chop it up as 0. 100 times 2 is 200 divided by 10 is 20. 300 divided by 10 is 30. 800 divided by 10 is 80. And then remember we multiply and then we add them all up. 8, this is 100, 30. Okay, so this is mu, but it's also the expected value. They both not represent, they both mean the same thing. So when you see in the instructions, find the mean of a probability density function, that means find the expected value. Okay. One more topic, which is, last one, standard deviation. This one takes a little longer because standard deviation is kind of a pain in the butt. Okay, so what we're going to do is we're going to find each deviation. So I'll just kind of write the step number. I'll put it back in a minute. All right, so we are going to, well, first of all, it tells us this expected value is 7, but we already knew that. We already knew the expected value, or the mean, is 7. So here we know that mu equals 7 when we do this right here. Okay, step 1, find each deviation. This is step 1. Step 2, square step 1. Step 3, multiply step 2 by the probability. Step 4, next add up. This is step 4. Take the square root. Step 5. Okay, so we're going to do all these steps, but I just broke it down so it's a little more palatable. I just dropped a bunch of papers because I needed my keyboard. Okay, so first off, step 1, it is the deviation between the data value and the mean. So this is 2 minus 7. It's going to be really hard for me to write what it is. I mean, I can write the answer, but it's going to be really hard for me to write like what I'm, maybe if I make it bigger. Let's see, 3, okay, not that hard. 3 minus 7 is negative 4. 4 minus 7 is negative 3. I won't write all of them. 5 minus 7 is negative 2. 6 minus 7 is negative 1. 7 minus 7 is 0. 8 minus 7 is positive 1. 9 minus 7 is positive 2. 10 minus 7, 11 minus 7, 12 minus 7. Okay. Now we're going to square that. Negative. Remember when we square things, it's always positive. So if you use your calculator or you don't use your calculator, it doesn't matter. Just make sure your answer is always positive. So we have 25. 4 squared is 16. 9, 4, 1, 0. And back up, 1, 4, 9, 16, 25. And now we multiply. So we did this concept in problem 1, where we multiply the probability times something, but it's not the same number, so we still have to do it again. So this is 25, so it's this step 2 right here, the mu minus the x minus mu quantity squared, and we're going to multiply that times the probability. So 25 over 36, 16 over 18, 9 over 12. We're doing row 2 over the probability, so this is over 9. Well, this has the 5 in it, but it's times 1, so who cares? 5. Gotta love me a 0. And then notice this pattern does show up here. We are going, because the probabilities had a pattern where they went big to small. And then step 2, row 2, had a pattern where it went like 25, 16, blah, blah, all the way down to 0, and then back up to 25. So since they both have patterns, the products repeat. 9 over 12, 16 over 18, and 25 over 36. Okay, next, now I need to get my calculator back. Now we're going to add all these up. Like literally, where did my calculator go? Hang on, let me close some things, see if I can find it. Nope, these are not it. Where's my, okay, I'll just make a new calculator. I don't know why it went all wonky on me. Okay, full screen. No, not full screen. This is the computer. Okay. Well, that was a pain. And now look, my Zoom is all off. Okay, remind me not to do that again because that was kind of a pain. Oh, but I was trying to write in tiny boxes. Okay, that's why I did it. Now we're going to add all these up. So I need to add up 25 over 36, 16 over 18, 9 over 12, 4 over 9, 5 over 36, got plus. I don't need to put the 0, but you could because it's easy to type. 5 over 36 again. And now there's a little shortcut here. Well, I guess part of the shortcut would be writing it correctly the first time, right? That should be a 9. Since it doubles, what did I just do? Hold, please. Since it doubles, you could, if you know what I'm talking about, you could just add up those 5 and then do times 2. If you don't know what I'm talking about, don't even worry about it. I'm not even going to do that. That's just a shortcut for those people that like fractions. Okay, so get rid of that 4. So now we have plus 4 over 9, plus 9 over 12, plus 1 over 18, plus 25 over 36. And we get 35 over 6, because this is to add everything up. Last but not least, this is take the square root of the result of b, which was the 4, and this is our standard deviation. So our standard deviation is the square root of 35 over 6. That is, here's our square root button, the square root of the answer, square root of 20. A lot of people don't like that. The square root of, I could just go up and highlight that and just do it like that, square root of 35 over 6. And we get approximately 2.42. Cool. Okay. Cool, except for like, that was a pain in the butt. That was a lot of work if we have to do that for every problem. So now let's talk about calculator shortcuts. Okay, so what we're going to do, we've talked before about probability functions and frequency tables, or specifically relative frequency being related. So we're going to take this whole table. It doesn't matter if you look at 1 or you look at 3. Well, 1's a little less messy. Let's look at 1. We want to take this whole table and we want to put it into our calculator. So you have these notes handy. So what I'm going to do is I am going to, oh no, I'll just type them in here and then I'll make it big after this. Okay. Go home. Statistics. So we've done this before, but maybe it's been since chapter 2. So maybe it's been a minute. So let's go over the steps again. Go to statistics. We have our list to type in our frequency table. I don't know if my head's in the way, but I'm just going to move my head down here just to make sure. And the X is the value. So 2 through 12 is going to go in the first column. So 2. And you could just hit enter, or you could hit this down arrow right here. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then I need to get the frequency. So I'm going to type in the relative frequency because this is a probability density function. We do not need to tell our calculator. The only thing you need to do is to make sure that the frequency, because it's a relative frequency, adds up to 1, because it's still a probability density function. If it does not add up to 1, this is the messed up thing. It'll give you the wrong answer and it won't even let you know. It'll just be like, you typed the wrong thing in, you get the wrong answer. So we have to be very careful that it adds up to 1. This does. We already talked about why it adds up to 1, so we are good here. So I'm going to type in 1 out of 36, and as soon as I do that, I get a decimal, but the calculator knows it came from 1 out of 36, so don't fret. We're just going to type it in the way we see it on the table, and then we'll let the calculator compute it however it wants. All right, 6 is 5 out of 36. Now remember, I'm typing what's typed. No, I'm not typing what I hand wrote. I'm typing what's in the black type in this table, because the handwriting was the work, and I just want the raw table. So let's see, 7 is 1 out of 6. These are all just long decimals. And then we have 5 out of 36, 1 out of 9, 1 out of 12, 1 out of 18, and 1 out of 30. Okay, I'm done with this for a minute, so I'm gonna make this really big. Really big. Okay, so here's our table. This is what it should look like. Again, gives you decimals, who cares? Let it do what it wants to do. So we're gonna go up and we're gonna go over to stat. Now remember, mu is the mean or expected value, and sigma is the standard deviation, because all of this adds up to 1, all, total, whole, that all means population. That means Greek letters. So go to stat, I'm going to go down, and here I have the standard deviation. The mean, which is mu, is equal to 7, and I have the standard deviation, which is equal to sigma, is that exact number that we have. We rounded it to 2.42, but now we have a much faster way of getting the answer. Now, I want to remind you that mean is mean no matter what. It doesn't matter if it is sample or population, mean mu, sample mean x bar, they both give you 7. But standard deviations are not all created equal. So standard deviation sigma versus sample standard deviation s, there's two different answers. So for probability density functions, we want sigma. Here we go. It is the population standard deviation. So now you have a nice little shortcut when it says what is the expected value to find the mean. What is the standard deviation to find sigma? Right, clearly, I need to end this video because I'm going to cough to death. But we will see some examples where it doesn't add up to 1 in the next video. So yeah, we'll see what to do then. You might already know, but yeah. So if you have any questions, shoot me an email. Otherwise, I'll see you in the next video.